Hello, my name is Jayden, and in this video, I will explain how can I find the tangent line of the fx equal x squared times sine squared to x at x equal 4, at x equal pi over 4. So the first thing first, I will find the derivative of the fx. So here, when we have the x squared times sine squared to x, the first rule I will use is a product rule. So I will so the formula of the product rule is the the derivative of the first term times the second term plus plus the first term times the derivative of the second term. So here is where I using the product rule, and then the first term is x squared. So the derivative of the x squared is 2x, and then times sine square of 2x plus x squared times the derivative of the second term. So sine square times 2x. I will use the chain rule. So the chain rule is I will need to is the chain rule. The formula of the chain rule is the derivative of the outside times the derivative of the inside. So over here we have to square is outside, so we'll do the power rule. We'll put the 2 in front, and then 2 minus 1 in the exponent will be 1. So 2 sine 2x, and then we need to find the derivative of the inside. The inside is sine of 2x. It's just so the sine 2x, the derivative of the sine 2x is cosine 2x, and we need to find the derivative of the 2x. So derivative of 2x is just 2, and we're done. So here 2x times sine squared 2x plus 2 times 2 is 4, so 4x squared times sine 2x times cosine 2x, and then I would factoring by 2x times sine 2x, because here we have 2x sine 2x, we have 2x times sine 2x here. So inside we have sine 2x because it's a square, and 2x for x squared divided by 2x is 2x cosine 2x. So we finished finding the derivative, and now we need to find the slope of the tangent line. So we do the substitution of x equal pi over 4 into the derivative function. And so here is where so I would just need to replace x into pi over 4. So here is where I did, and then reduce this by 2, so it will be pi over 2 times sine 2, pi over 2 again, 2 times pi over 4 is pi over 2, and then 2 times pi over 4 is again and again. So to find the value of the size of pi over 2, remember in unit circle pi is 180 degree. So pi over 2 will be 180 degree divided by 2 is 90 degree, and sine 90 is 1. And if we look at the decimal, here I have the function y equals sine x. So over here pi over 2, which is 90, so sine 90 is 1, and so the sine 90 is 1, the cosine will be 0, the cosine of the 90 will be 0. So here 1 sine pi over 2 is 1 pi over 2. We still put the same because there's no trick here. And then cosine of 90 degree pi over 2 is 0, so the slope will be pi over 2. And then the next step, I will find the y value of the y value when x equal pi over 4. So I just need to sub x equal pi over 4 into the first function. So here's the first function here. So will be pi over 4 all square sine times sine square to time up to times pi over 4. So here will be equal to pi square over 16. For square will be 16 sine, and then times sine square of pi over 2. And pi sine pi over 2 is 9 is 1. So and 1 square will be is still the same. So the y value will be pi square over 16. So we have slope, we have x value, we have y value. Now we just need to find the b value. So I sub all the value into the new equation y equal mx plus b. So here where I substitution, and then I just need to reduce pi over 2 times pi over 4 will be pi square over 8, and then I just need to change this side here to the other side. So and when we change the other side, we need to also change the sign of the values. So it will be negative pi square over 8, and then we need to find the same denominator, and the same denominator will be 16. So we just need to so I just need to multiply by 2 in the both numerator and denominator. So it will be 2 pi square over 16, and pi square minus 2 pi square will be negative pi square over 16. So here is the b value. So therefore the equation of the tangent line will be y equal pi over 2 x. Pi over 2 is the slope, minus pi square over 16. Negative pi square over 16 is the b value. So that's how I do for the first question of the Unit 3 test.